Okay, welcome. Today we're going to talk about matrix multiplication. And this is a little more complicated as compared to matrix addition and subtraction. So that's why we're going to have a longer form video on it. We're learning about scalar by matrix multiplication and matrix by matrix multiplication. Matrix by matrix multiplication will employ a technique called the dot product method. And this could even be useful in real life.
Impossible.
Yes, maths can be useful in real life. So let's get into it. So first thing to understand the order for matrix. The order for matrix is the number of rows a matrix has multiplied by the number of columns. It's commonly expressed as a number. So the number of rows is first, put the multiplication sign, then you put the number of columns. The order for matrix is important for all the operations. For example, in matrix addition and subtraction, you need to have the same order. And here we have a next example of a matrix order. This is a 2 by 3 matrix, 2 rows, 3 columns. But yes, the order for matrix is important for addition and subtraction. You can only add and subtract matrices that have the same order. And that makes sense, right? They have to fit with each other. These here don't fit. This is a 2 row, 3 column matrix, or a 2 by 3 matrix. And you're trying to subtract a 3 by 4 matrix. They don't fit, so the order, it won't work. They don't have the same order. And that's a rule for addition and subtraction. Trying to add a 2 by 3 matrix, a 3 by 4 matrix, is like trying to shit in the sink. It doesn't work that way. Don't shit in the sink. Please don't. Alright. So let's see the effect of the order for matrix in multiplication. Firstly, we have the scalar by matrix multiplication. Now in scalar by matrix multiplication, a scalar is just a number. It's the number 5 here. We're multiplying this with a matrix. This is a 2 by 3 matrix. 5 is not really a matrix. It's like a 1 by 1 matrix, but it doesn't matter because it acts like a scalar. It's kind of like multiplying with brackets. It doesn't really matter. So for each number, you just multiply by 5, just like how if it was a bracket. So it's 5 by 5, 25, 5 by 3, 15, 5 by -1, -5. You get the concept. That's the scalar. That's the scalar by matrix multiplication. That's an easier concept to understand. Now let's get into the matrix by matrix multiplication. In this instance, the order of the matrices is going to matter, and it's going to matter a lot actually. For matrix by matrix multiplication, you can only multiply two matrices if the number of columns in the first matrix is the same as the number of rows in the second matrix. So in these two matrices here, 2 columns, 2 rows in the second one, so you can multiply them because 2, 2, they are the same number. That's the only condition you need to multiply them. They don't have to be the same order, but the first one must have the same number of columns as the second one has number of rows. Here are some examples of compatible matrix multiplication. 2 by 4, 4 by 1. Number of columns is equal to number of rows in the second one. 2 by 2, same number. 1 by 1, same number. Compatible. Here, the number of columns in the first matrix is different than the number of rows in the second matrix. Incompatible. These two numbers have to be the same, or else it will not work. What is the main concept? Well, they are going to multiply the columns in matrix B by the rows in matrix A. So 1 will multiply with 5, 2 will multiply with 7, 1 will multiply with 6, 2 will multiply with 8, and that is the main concept. Alright, so let's get into this matrix by matrix multiplication and the dot product method. Here we are in the website Maths is Fun, a very good website if you need to learn some maths. So to multiply this matrix by this next matrix here, first off, they should be compatible. How much columns does this matrix have? It has 3 columns. How much rows does the second matrix have? The second matrix has 3 rows, so they are compatible. Now let's start multiplying. The rows in the first matrix will multiply the columns in the second matrix. It's a dot product method of multiplication. You'll get one answer, and that one answer will come right here. So let's see how it goes, right? So 1 will be 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11. Eventually, that'll give you 58. and you just put 58. That's the answer. So the other rows, you'll do the same thing. Let's try to get this number here. It'll be 1 multiplied by 8 plus 2 multiplied by 10 plus 3 multiplied by 12. Add them up and you get 64. Eventually, if you keep doing this process, you'll end up filling out everything. If you take this row here, so the second row, and you want to multiply the same columns, same method. 4 multiplied by 7 plus 5 multiplied by 9 plus 6 multiplied by 11. Then you'll fill out here, you'll get 139. Here you'll have 154. That's the concept. And that is called the dot product method. Now, why do we multiply this way? Does it make sense to multiply this way? It's kind of odd, right? But let's see. If you go to a shop, and this shop has apple pies that cost $3, cherry pies costing $4, blueberry pies costing $2 each. How many will they sell in 4 days? Well, this is how you label it, right? So you have the days, then you have the types of pie, and we have the amount they sold. So the number of pies they sold, right? So if you want to get the values, what would you do? Well, it'll be apples. There are 13 apples. The cost of one apple pie is 3. So 13 times 3 plus 8 times 4, 4 is the cost, plus 6 times 2, 2 is the cost. And then you get 83. So the total amount you get on that day, on Monday, will be 83. So if you want to write the total amount you have, you'll just put 83 there instead of putting all the numbers. Just like how above here, when you do the dot product method, with this row and that row, you can put 58 as a replacement. If you put in value, if you're talking about the value of money made in one day, you'll put 83 as a replacement. That's the concept. Dot product method, you use it in real life. If you want the values for the other days, so Tuesday, Wednesday, Thursday, you do the same thing, and these are the money you made on the respective days. And that right there, that is matrix multiplication. If you put this in matrix form, this is what is happening. We have the amount sold, and then we have the values. You multiply the same way, the same matrix way, and then we get our answers in money for each day. Now, there's a way to know exactly what matrix you'll get, or what order of matrix you'll get when you multiply two compatible matrices. This is how you know. If I multiply matrix M times N with matrix N times P, the order of the new matrix will be M times P. So let's test this out. A 1 by 3 matrix multiplied by 3 by 1 matrix. Our answer will be one spot. This is a 1 by 1 matrix. So how do we know it's a 1 by 1 matrix? This one and this one. When you multiply, eventually the answer will have this order. Let's try a 3 by 1 multiplied by a 1 by 3. What do we end up with? We'll end up with 3 by 3 matrix, or 3 by 3 matrix. So you can tell what the order of your matrix answer would be when you multiply. There's matrix identities. They operate just like normal identities. So a matrix identity in terms of multiplication would be the number, sorry, not number, but it would be the matrix C that you can multiply another matrix by that will give you back that matrix. Like how 5 times 1 is 5. 1 is the identity of multiplication. Well, this is the identity of multiplication, but for matrices. If you multiply our matrix by this, you'll get it back. That's how it works. Last thing to know about matrix multiplication is that unlike normal multiplication, matrix multiplication is not commutative. 3 times 5 is equal to 15. 5 times 3 is still 15. The order doesn't matter. But in matrix multiplication, the order does matter. Matrix A multiplied by matrix B is not equal to B multiplied by A. And that's because of the way it works. It's rows multiplied by columns. So you can have different combinations depending on what you do. And we have proof from earlier on. These were the same matrices. When you had this one in front, you got 32. But when you had this one in front, the 4, 5, 6 in front, the 3 by 1, we got a whole different set of values. So the order of multiplication matters as well. Let us get some final practice in. We'll multiply this 3 by 2 matrix with this 2 by 3 matrix. And let's see what the answer will be. Now we know, just from watching the question, that the answer will have an order of 3 by 3 because of the rule. It'll be a 3 by 3. That's the order. But let's get into the answers now. So we're going to multiply all these columns by the first row. All of these columns by the first row. The first row is 3, 4. Multiply all these columns by the first row. So 3 times 3 plus 4 times 6, we'll have 33. And that'll be in the first spot right there for the first column. Next column, the 1, 9 column will multiply by 3, 4 again. 3 times 1 plus 4 times 9, 39, 39 down there. Next, 3 times 5 plus 4 times 7, so 15 plus 28, 43. 43 comes there. We finish with the first row now, so go to the second row. 7, 2. So 7, 2 times 3, 6. 7 times 3, 21. 2 times 6, 12. Add them together, you get 33. 33 comes back here, coincidentally. So next column now, this column here, multiply with the same 7, 2. 7 times 1, 7. 2 times 9, 18. Add them together, you get 25. So 25 comes right there. 7, 2 times 5, 7. 7 times 5, 35. 2 times 7, 14. Add them together, 49. 49 comes right here. Almost done. Nearly finished.
Approximately 10 hours later.
5 times 9. Sorry. 5, 9 times 3, 6. 5 times 3, 15. 9 times 6, 54. Add them together, you get 69. 69 comes in this spot. 5, 9 times 1, 9. 5 times 1, 5. 9 times 9, 81. Add them together, get 86. 86 comes in this spot. And to top it off, to finish it off, 5, 9 times 5, 4. 5 times 5, 25. Plus 9 times 7, 63. Add them together, you get 88. And 88 will come in this spot. And that right there, my friends, is matrix multiplication. It's kind of complicated at first, but you have to just keep doing more questions and you'll have the full hang. Good luck in all your endeavors. Thanks for everything. I'm from the client not pay me. Drive by in a St. Mary. From putting at the you have to pay me. If you just leave the video.